The graphical interpretation of average velocity relates to the slope of the line between 2 points on the graph. On the graph that you see in front of you, there are a number of points. The slope between any 2 points is the average velocity. So the blue line that is on the screen has a slope. That slope is calculated using the slope equation, change in y over change in x. If you're not familiar with how to calculate slope, go back and watch the video on slope. And then that slope is for that line represents the average velocity between the two data points. The average velocity between A and D is different than the average velocity between A and C, which is different than the average velocity between A and F. In the case of looking at this as this object moves along, it starts at a position of about 50 meters, 40, 50 right here. It moves along its path. Now, this is representing linear motion, so you could almost think about this in this fashion. If this is my start point, and this is 100 meters up here, my end point, my object starts somewhere in the middle, and then it moves forward almost to 100, and then it moves backwards down that same line and ends up about 20. That whole thing happens over 5 seconds. So to understand where the object is at any given period of time, we graph the position at a given time. And so at about 2.5 seconds from the start, I am up at the top, very close to 100 meters. Later on, when I get to the 4-second mark, I am almost back to where I started. Yes, in the graph in front of us, the location is over to the right, but remember, the x-axis is representative of time here, not of a physical position. So the object is moving forwards and backwards along a straight line. As different average velocities, the green average velocity, the average velocity between A and C, is greater than the average velocity between A and D. The average velocity between A and F is a negative velocity. And so the velocity is changing as we move through this curve. We also have a concept called instantaneous velocity. Instantaneous velocity is the velocity that occurs at any given point. In geometry, you learned about the circle, and you learned that there are 2 ways that lines can interact with the circle. One, they can pass straight through the circle, and in this case, it touches the circle at 2 points. We call that a secant line. And then there are lines that go near a circle, touching it at one point, and those lines are referred to as tangent lines. There's a tangent line right here. If this tangent line was tipped ever so slightly, same point, but it's tipped just a little bit, what we experience is that the line passes into the circle and becomes a secant line. There's only one angle in which the line travels past the circle, touching the circle, and doesn't enter the circle at a given point. And so that is called the tangent line. Each of these points on our original graph, A, B, C, D, E, and F, each have their own unique tangent line. So the tangent line to E may be actually straight up and down. You could see as we are moving along, it passes through the circle, through the path. At F, the tangent line may look more like this. At B, the tangent line may look more like that. And so as we go through this graph, what we find is that the steepness of the slope from A to B becomes greater. That means the velocity becomes greater from A to B. From B to C, the slope becomes a little less, so it's slowing down. Right up at the very top of the curve, right up here, the tangent line is actually parallel, which means that the object comes to a stop for a short period of time before its velocity becomes negative again, or negative for the first time, right here between C and D. And so the tangent line is the point on the line that touches a single point on the graph. It is the slope of the line, the tangent line, that gives us the instantaneous velocity. The average velocity of a line, of a curve, is the slope of the line between any 2 points. If the graph is linear, and what I mean by that is we have a graph that looks something like this. This is a position time graph here on your screen. In this position time graph, what you find is that the instantaneous velocity and the average velocity are the same. When the velocity changes, so we get a different slope at some point, then we find that the average velocities and the instantaneous velocities are no longer the same if we are looking at it through past the point of acceleration right here.